What's up? Today is 24 to 2025, bar 24. And so far, we're gonna do uh, dynamic or graphs. Yes, can everything. Uh, let's do graphs. Rotting oranges. Or says full house rubber 2. Cool. So we can go with 4 and I guess we could do meeny, miny, moe, catch that tiger by the top. So miny, moe. And yeah, there we go. House robber part 2. Right, I remember this one. And it's from a previous video of mine, which I basically, it's basically, what's this again? It's kind of like this one, except that makes sure that it takes the maximum between rob 1 and rob 2. So 1358 that would be okay. Wait, I don't know, since it's to initialize rob 1, rob 2, have 0. And how we're gonna basically what we're looking for is you're gonna find either in index 0 and index 1 which house we can rob without the maximum money we can rob without alerting the police, which is you cannot rob twice at adjacent things, so you have to rob jumping rob or something like that. Yeah. Basically, this algorithm makes sure that it assigns the maximum between the from one and rob two between the temp. Assign rob two to rob one, assign temp to rob two, then return rob two. So how does this work? So this is we're gonna do house robber, but let me just I guess let me just review this so that I can get the background on how to solve house robber too. So basically the idea here is we can say that this is the example 1358 and we know the best the 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 maximum we can get here could be 11 since we can actually start in this one. I'm pretty sure we can. Stop. 2, 10, 16, 9, 2, 3, 2, 3, 4, 5, 6. So it's not, should start here. It's 9 plus 3 is 12. But yeah, no. Yeah, this is actually the biggest. But basically, the idea here is that once we iterate over the nums array, which is a list, this is the nums array, and for each number, get the 1. So 1 plus rob 1. Rob 1 is still 0, so it's 1, and then this one is 0. So we assign the maximum between these two parameters, which is we know it's gonna be this one first because it's the one that's gonna stack it. We put it into temp, and then we put rob 2, which is 0. Now rob 1 becomes 0 as well. Temp, and rob 2 gets the value of temp, which is 1. So now the next iteration is now 3. So we can see 3 plus rob 1. Rob 1 is now 0. So 3 plus 0 is 3. And rob 2 will be 1. And then we assign, now we get the maximum, which is 3. 3 goes to temp. Rob 2, which is 1, now becomes, which was 1. Now rob 1 becomes 1. So that means this 3, 1. You can see that it's now 3. This is 1 now. And within tap, which is now 3. Rob 2 gets the value of 3. So now it's 3. And next iteration, so 5. So 5 plus 1, which is now 6. 5 plus 1 over 3. If I'm right. Yep. It's 5 plus 1. And then this one is 3. So it's bigger. 6 or 3. 6 is bigger. So we assign the value of them to 6. Rob 2 is now 3. So rob 1 now becomes 3. Then assign the value of 6 to rob 2. So now rob 2 is 6. Then we're now at 8. So 8 plus 3, which is 11. And then between 6 between 11 and 6. 11 is bigger, so we assign 11 to temp. 6 now goes to rob 1. Temp now goes to rob 2. So rob 2 was 6, so rob 1 becomes 6. And temp becomes, which is 11. Rob 2 now becomes 11. And we can see that the biggest one is actually 11. So 3 plus 8, 11. And after that, the iteration, return round 2, which the answer is now 11. And it's quite interesting, the the algorithm on how it's solved. It's basically, I think it's top, no, no, it's not top down. It's actually space optimized. All right, so let's start now with solving. I'm gonna watch the video if I don't get it. So now I'll read it. You are given an intermediary grade lumps where lumps at index I represent the amount of money the house has. The houses are arranged in a circle, i.e., the first and last name house are neighbors. You're planning to so it's more of a circle rather than one straight line. You're planning to rob money from them, but you cannot rob two. Yeah, it's the same thing. So what Joyce and Hobbes were both working at what? 3, 4, 3. So 3 and 3 are neighbors. Three. Oh, you can't do this because they're technically neighbors. Yeah, just this one. Sample 2, 8. And we can't rob this one because they're neighbors as well. So 9 plus 3. No, no, no. 2 plus 8 is 11. But you can also snubs at index 1. What? Wait, you can. Oh, okay. So you can actually stick it much larger. 9 plus 6, 16. I'll watch that.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve House Robber 2. We already solved House Robber 1 and I would recommend watching that video or at least solving that problem first before this one because this one is very similar. So basically the premise of the problem is the same. We're just trying to maximize the amount that we can rob, and in this case we have a street, aka an array. So this is our array. We want to maximize the amount that we can rob. The only catch is that we can't rob two values that are adjacent to each other because it's like two houses that are together. We can't rob two houses that are right next to each other. We have to choose one. So we can either choose the 2 or we can choose the 3, right? So that's basically House Robber 1. Now there's one more catch with this problem. In this case, the houses are actually arranged in a circle. So we have this as our array, but really this is what our array is going to look like. The 2 goes to the 3 goes to the 2, and then the 2 goes back to the 2, right? Basically what we're saying is this last value is also adjacent to the first value. So it's literally that simple. That's the only difference between House Robber 1 and House Robber 2. And actually, the good thing is you can reuse the solution from House Robber 1 to solve this problem, and I'm going to show you how. So let's just remember House Robber 1 first of all, right? So we have this array, right? We can choose the houses we want to rob, but we just can't rob adjacent houses. So I'll explain at least a little bit about how we solved House Robber 1. Basically, it's kind of dynamic programming, and you can watch the first House Robber explanation if you want the basic, like the better explanation for it. But basically, okay, what's the max we can rob up until this point, right? That's 2, obviously, right? So we remember that. Okay, the max we can rob up to here is 2. Okay, what's the max we can rob up until here, right? Clearly, we have to make a choice. We can either rob 2, right, and then nothing from here, right? We don't rob here, and in that case, the max we could rob up until this point would be 2, but we know that rather than robbing house 2, right, we don't even carry this value forward, we just rob house 3, right? So then we can put a 3 here. So up until this point, the max we can rob is 3. Now, lastly, what's the max we can rob up until this point where we're looking at the entire array, right? Whatever value we put here is going to be our solution. So now we have two choices, right? we can rob house 2, skip 3, and then rob up until this point, right? And the value for here is 2, right? So 2 plus 2, we would get 4. Or we can make another choice. We can actually skip this house and just carry over the value that we computed before. What's the max we could rob from here, right? That's 3. We would just put the 3 here. Now, clearly, the first one that we computed was 4, so that's greater. The max we can rob for the entire array is 4. Now, I like House Robber 2 because it requires us to reuse the solution from House Robber 1 in a slightly clever way. It's not even about algorithms at this point. It's more about reusing the solution. It's about, having a function. So the only restriction here, right? You see up here we robbed, like we were looking at, okay, what's the max we can rob from the entire array? The only restriction here is we can't use the same solution from here over here, right? The max we can rob from the first array is 4 with House Robber 1, but with this, if we rob this, skip this, and rob this, we're not allowed to do that because remember, the first and the last house is connected. Basically, what I'm saying is if we rob house, like the first house, we can't rob this one. Or if we rob this house, we can't rob this one. How can we reuse the solution from up here? Let me show you. Let's say this is our helper function, right? House Robber 1. We can basically say, okay, we can run House Robber 1 on the entire array except the last value, right? And what's that going to give us? It's going to give us a 2, right? We can also run the House Robber 1 helper function on the entire array except the first value, and that would actually give us a max rob of 3. I think for this one it would also be a max rob of 3, right? But basically what I'm saying is we kind of have to run the helper function twice on different subarrays of our input array because we're not allowed to rob the first and the last house together. So if you actually understand House Robber 1, right, the helper function that we're going to use, and you understand what I'm saying over here, right, where we're not allowed to rob both the first and last house, then all you have to do is call the helper function twice on these two subarrays, and whatever one is the max is the value we're going to return. You can see in this case, from the first array, the max you can rob is 3, right, if you rob 3 and skip the first house, and if from the second array, the exact same thing is true because this is a pretty symmetrical array. So if you skip house 2 and rob this one, this 3, you also get a max rob of 3. So that's going to be the solution. But it could have been different technically, right? Maybe this could have been a 5, right? And in that case, the max you could rob from the first subarray would be 5, skip the 3. So then 5 would be our solution, right? And once you can basically identify this problem, it's pretty straightforward. And so since if you might remember, the House Robber 1 algorithm is a linear time algorithm, O of n. All we're doing is calling that same algorithm twice, so the time complexity is going to be big O of n, right? And the memory complexity is going to be O of 1 because we don't really need any extra data structures for the most part. So now let me show you the code, and it'll make a little more sense. So first, I'm going to create a helper function, right? Basically, what I'm going to put here is our solution from House Robber 1. If you remember, we have two values, rob 1 and rob 2. Basically, these store the max amount you can rob.
So do the first helper function here and a helper 2 function for the checking. I'm not sure what helper 2 is. Yeah. Okay. Yeah. Okay.
from the previous two houses, right? And initially we can set them to 0, right? We can just assume that there's two random houses that come before our input array, and both of those houses are value 0, or however you want to call it. But we are going to have to go through every number in the input array, every house, right? And so how are we going to compute what's the max we can rob up until this point? I'm going to store that in new rob, but you could call it something else. How are we going to compute that? Well, we're going to take the max of the current house that we're at, right? N plus rob 1, right? So rob 1 plus n, because we're not adding rob 2 to this, remember, because we have to skip rob 2, right? We can't rob two adjacent houses. We can't
Oh
add
yeah.
rob 1 and rob 2 together because those houses are adjacent, right? N is adjacent to rob 2. We can't add those together. But this is one solution. We're skipping house 2. Or if we decide we do want to include rob 2, then we're not allowed to include rob 1, and we're not allowed to include n. The other choice that we have is just rob 2, right? So we want the max of these, which is going to tell us up until the current position that we're at in nums, what's the maximum we could rob. So this is the new rob, right? And since we're continuing to iterate through the array, we're going to continue to update rob 1 and rob 2. So since we're shifting by 1, we're going to assign rob 1 to the previous value that was at rob 2. And we're also going to update rob 2 with the value that we just computed, new rob, right? And basically, once we've gotten to the end of the array, rob 2 will contain the max amount that we can rob from the entire input array. So after the loop, all we need to do is return rob 2. And so now that we've gotten our helper function done, we've basically solved the problem, right? But there's just a couple edge cases you have to worry about. So we're going to call
Neighbours.
our helper function, right? And remember, one of the cases was we're going to skip the first house, right? So we're going to call the helper function skipping the first house. How can you do that? In Python, you can just say pass in the entire array starting at index 1, right? So we're skipping index 0. So we're skipping the first house, right? So that's one call that we're going to have to make to our function. We're also going to have to make one more call, right? And this time we're skipping the last house. So you can do that in Python like this, right? So -1 is
-1.
basically the last index, and we're saying we're skipping the last index, right? But mainly I'm calling the helper function, passing in the entire input array except the last house. That's what I'm doing. So we've computed these two values, and we want the max of them. So we can just take the max of the values.
Oh, that's actually pretty short. So you don't need to do a helper to function. So I basically call some helper from starting from index 1. So helper from this up until -1. So that's one. Yeah, get the max.
That these two functions return. Now, there's one last edge case we have to worry about. What if we got an input array with only one value in it? In that case, the max of this would end up being 0, right? But
0.
that's not necessarily true because we're skipping the
So
first house here, so we're passing in an empty array. We're skipping the last house here, so we're passing in an empty array, right? But technically, a solution could just be the first and only house if we only had one house in our input array. So we're actually taking the max of 3 values here. And one of those values is literally just the first house by itself. So the maximum of these 3 is going to be the max that we can rob, so then we can just return that value. The convenient thing about Python, at least, is that you can actually take the max of 3 values. And don't forget, actually, in functions in Python, you have to put self as one of the first parameters. So now you can see that this is a valid solution, and it's pretty efficient because this is a linear time algorithm, big O of n. And that's all. if this part isn't clear, like the helper function, I would watch the first video for House Robber 1, which I made a few months ago, and I hope that this is helpful. If it was, please like and subscribe. That okay, the max up, then we can put it whatever we with House 1. Or if we resolved House Robber 1, basically it's kind of dynamic programming, and you can watch the first House Robber explanation if you want the basic, like the better explanation. That's 2, obviously, right? So we remember that. Okay, the max we can rob up to here is 2. Okay, what's the max we can rob up?
All right. Thanks for watching. Okay. Basically the same idea, except splicing it. Getting the max between nums at index 0. It's just one enough. But we can also make it not nums than 0. There's no nums in the list or the class. So, and I think that's good now. And there's something else. And memoization. Different functions. German site, yes, it's not gonna it won't go on this out of scope.